onwards, never forget it. D by dx of x raised to n is equal to, because y is a function of x with the power n. Then this is n into x raised to n minus 1. Very, very simple. Example I am writing, y is equal to x raised to 6. When I write y is equal to x raised to 6, the differential of this is dy by dx is equal to d by dx of x raised to 6. d by dx of x raised to 6, that is equal to, in the place of n here it is 6 only. Therefore, this ratio 6 into x raised to 6 minus 1. So in the beginning, I have to teach you like this only. N into x raised to n minus 1. 6 minus 1 is equal to 5. Therefore, the value is differential 6 x raised to 5. You got it? That is earlier also I said the power relation, power functions, I will tell you later. This is the condition, right? Another example I am writing. Yes. That is simply you can say d by dx of x raised to d by dx of x raised to 6 is equal to 6x raised to 5. Because 6x power becomes down by 1, right? Decreased by 1. 6x d by dx of x raised to 7 is equal to 7x raised to 6. d by dx of x raised to 100 is equal to 100x raised to 99. Like that it goes. Suppose that the function is like this, y is equal to 5x squared. That will be wrote earlier, right? Then dy by dx is equal to d by dx is equal to d by dx of 5x squared. This is cx function, right? Yeah. Then this case of 5 is taken out. So that's 5 into d by dx of x squared. X square means 2 into x raised to 2 minus 1. 2 minus 1 is equal to 1 only. Right? This is equal to 5 into 2 into x raised to 2 minus 1. Therefore, this is equal to 5 into 2 into x raised to 1. That is equal to 10x. Very, very simple, right? But concentration and interest. Without interest, you will become a zero. You have to create interest to learn physics. So all these mathematical conditions, when you understand, then it is very easy to go with physics. So this is what's called power rule. So power means y is equal to x raised to dy by dx is n into x raised to n minus 1, right? Done. This is also done. Very simple examples also give. I think you understand it, what I'm teaching today, and also note it time to time. Another one is exponential function. For exponential, if it comes like this, in physics, we have to come across exponential function also sometimes. Exponential functions. Exponential function is e raised to x. E raised to etc. etc. Y is equal to e raised to x. Therefore, dy by dx is equal to e raised to d by dx of e raised to x. There is no change, that is e raised to x. So the exponential functions when differentiated, there is no change in that. Am I correct? But suppose that the function is, this is a e raised to 2x it is coming. E raised to 2x is abnormal. Normal is only e raised to x. Here a 2x comes, some abnormality is not is coming. E raised to 2x is not same as equal to e raised to x. This is exponential all the same, but there is some difference with the normal function, right? In this case, you have right, put 2x is equal to u. First of all, make it in the normal form. Then this becomes equal to e raised to u. So now y is a function of u and u is a function of x. In that case, how we'll do it? Then this is dy by dx is equal to d by dx of u, d by dx of y is equal to e raised to u. Into what? Into du by dx. D by dx of u is equal to 2x. Right? Function of a function rule. Because y is a function of u is a function of x. In that case, how differential already explained. First is d by dx of d by du. Sorry. D by du of y. Because y is a function of u. A function of u is differentiated with respect to u only. D by du of y dy by du into what? Du by dx. Now this can be explained. This is equal to what? D by df e is equal to e raised to u only. As I said, normal condition, exponential function is when differentiated, you will write as it is into d by dx of 2x. What you will write? That is equal to 2 into d by dx of x. You will write this answer. That is equal to 1. Therefore, the value is equal to 2 e raised to u. But what's the value of u? U is equal to 2x. Then by putting that one, that is 2 into e raised to 2x. This is the differential of the function. So you have to go through every word I have said in a sequence manner, then you will understand it. So this case also comes. If it is a normal condition of the of the exponential form, there is no change. But some abnormality comes, then that function becomes a function of a function rule we have to apply. This is the only thing. Next is what? Logarithm. This is very, very important rule I am going to tell you now. Logarithm. So this class goes longer, no problem, but this long class will be divided into small, small parts. But you have to see very carefully logarithm. Suppose logarithm also is y is a logarithmic function. Y is equal to log x to the base e. Wherever the logarithmic function, there is a base, right? Okay. Now dy by dx is equal to d by dx of log x to the base e. It is not log e raised to x, log x to the base e. Right? This is the condition. So this is the whole part. The logarithmic function is called. This is equal to 1 by x. This is equal to 1 by x. Am I correct? In this case, also function of a function rule can come. Right? This is the simplest rule I am giving you. Right? Now, if the function is like y is equal to log x to the base 10, x to the base 10, then this can be written as equal to dy by dx. dy by dx is equal to d by dx of log x to the base 10. Log x to the base 10 or log x logarithm can be at the base e and also to the base 10, right? Most of the time in calculations, we are using logarithm to the base 10, right? In detail, the mathematics students will learn that, but bio students, that is not necessary. This much only is needed. So logarithm to the base 10, how it is differentiated, then this value is equal to differential equation simply x to the base n is 1 by x. Here it is equal to 1 by 2.303 into x. A constant also will multiply with x. This is the only thing. So today onwards, you will remember that. What is d by dx of log x? Suddenly you will see d by dx of log x is equal to 1 by x. That also done. Right. Next is the differential coefficient of trigonometric ratios that I am going to finish today's class very soon, right? Okay. So logarithm function also over. Now these are simple rules you have to only keep in the mind. Mind means very, very by hearted. This is the lifelong property of lifelong property. As a lifelong property, you will keep in your mind, in your memory bank always. Anytime asked, you will speak. TBD to sinus, trigonometrical functions. Trigonometrical functions are how differential coefficient can be calculated. First one, d by dx of sin x. Y is equal to sin x. Therefore, d by dx is d by dx of sin x is equal to cos x equal by rule only. D by dx of sin x is equal to cos x. There is no proof. Rule. Right. And also d by dx of cos x. D by dx of cos x is equal to minus sin x equal by. Again, d by dx of tan x. D by dx of tan x is equal to sec square x. You will see secant square x, sec square x. D by dx of cot x is equal. D by dx of cot x is equal to minus cosec square x. Again, d by dx of sec x. Sec x is equal to secant x tan x. Sec x tan x, very important. And last is d by dx of cosec x. D by dx of cosec x is equal to minus cosecant x cot x. Cosec x cot x. So these are the rules. All these rules you have to write. This is very, very important. D by dx of sin x is equal to cos x. D by dx of cos x is equal to minus sin x. D by dx of tan x of secant square x, sec square x. D by dx of cot x is equal to minus cosecant square x. D by dx of sec x is equal to secant x tan x. And the d by dx of cosecant x is equal to minus cosecant x cot x. So these are the rule related to differentiation. Today I taught this part of calculus called differentiation. And today this much only. Thank you very much. We will come tomorrow with another part of mathematical tools. That is also the part of calculus only, that is called integration. Till then, bye bye. Thank you very much.